Alright, so for this video we're going to look at powering a LED and some things you have to be aware of. So the first thing is power. Okay. Now most LEDs are like 3.2 volts or something. I mean, sometimes they're 3 volts, but very rarely do I find a 5 volt LED unless I have to order it through Mouser or something like that. Most of the power that comes out of your Arduino is 5 volts. Now, this is saying that if you overpower an LED, that it could fry or at least glow really bright for a limited amount of time and then slowly die off. And slowly being said that it might take weeks, it might take months, it might take 2 seconds. You just got to be very wary about power, okay, and how it works. Now, I want to try to integrate some electronics into this, no doubt about it. You have to, because it's a topic, and then programming is also a topic. So we can turn down power via the actual code, and that's called pulse width modulation. We'll get into that here shortly, but for right now let's look at maybe just running power to an LED straight off and some of the concerns that you have to have. Okay, first off, let me take apart the set experiment and get your breadboard to kind of look like this. Breadboard 101. First off, this side right here, this blue starting, goes from here to here. All the way down, all these holes are the same. So you can think of like a wire running from here to here. Anything that I plug in on this blue, I can bring over. So this is my negative side of the rail. This is my positive side of the rail. So again, this one and this one are the same. Now that being said, this is separated by 2 halves. So if I plug in a positive here, it is definitely not going to be over here unless I run a wire from here to here, therefore charging both sides of the breadboard. So this breadboard is divided into 2 sections. And we do that because of like ICs, microcontrollers, things like that could get plugged into the center. Now, the center part, it's kind of a little bit different. Instead of running up and down, we run right and left. So this hole right here is the same as this hole right here, all the way across. You'll see these little numbers on them. You'll notice that, like, here's number 1. Okay, number 1 and number 1 are the same. There's also little letters. So if you look here, and I think this is completely upside down, but that's alright. This is L1. And we'll pretend that I can see over here, this is F1. So F1 and L1 are going to be the same. Alright. So if I hook this up right here, this is stating that there's going to be a negative. It goes to this little rail, and if I want it to jump over to the other side, I have to go like this and jump the negative over to the other side of the lobe. And here's my positive that doesn't jump over there. So on your microcontroller, there's a couple variations of power. There's 5 volt, 3 volt, or 3.3 volt, and ground. Okay, on this side, this is raw power. And if any time that you're hooking up an LED to this stuff, you have to make sure if it's the 5 volt, you use a resistor. Okay. Now, experiment with resistors. We'll get into resistors here in the next little section. For right now, I'm just going to say this is the red resistor. Okay? Red. And look at the little stripes on it. So, let's say this 5 volts gets hooked up to this LED. Again, if I don't limit its power, it'll just fry it. Well, let's go like this. So this is my Kathy side and anode side. And if I wanted to bridge the street for the breadboard, I would hook up the fancy resistor from the positive. So now it's running a rail across. And I'm just going to bend this down to make it easier to look at. Okay. Let's zoom in just a little bit. Hopefully I can do that. Whoa. This is a digital camcorder, so I have to kind of ease into it. There we go. That's a little bit better. Perfect. Now we'll need some longer leads. So we're just going to power it to make the LED go on. We got negative. So if we want to power that rail for negative, we can go like this. Plug that into negative. And plug this into negative. That's why I like using wire, because I can really cut these to exact length. And it becomes a little easier. With the other ones, like these come in a lot of different variations of length, but I like keeping these very, very short and succinct. If you need to cut little leads, there's a trick to that I wish somebody would have showed me when I was a kid. Check this out. So here's wire. I cut a really long section off, like 3/4 of an inch, and then I cut right here. So I get something that looks like this. And then I slide the casing down. And there we go. We got a nice little jumper wire. So if you see these little jumper wires and you want to make those, that's an easy way to do it. Alright, so let's hook up the positive side of the street. So we'll hook this up to the 5-volt. And you can see, voila, comes on. And it's pretty bright, right? Now, if I was to take this LED and move it down, it'll fry out right off the bat because it needs the resistor right there, because this is a 3.3 volt LED. We'll get into calculations and all that good stuff here in a little bit. Now, if I wanted it just as bright without the resistor, I can hook it up to 3 volts. Okay, that's why I have it kind of hooked up like this, so I can move this over to this side of the street, and you can see right now 5 volts, super bright, and if I'm fast enough, it won't fry out. It gets warm though. Let's hook this side to 3 volts. I just have to make sure that's 3 volts. Yep, cool. So now 3 volts without the resistor, just as bright. So this side is just straight power. This is coming right off your USB. And anytime that you need something with absolute power, you use these. But if you need something with triggered power via digital or pulse width modulation, you start going to this side of the street. So that's what we're going to be looking at, is digital, analog, and what that means for the LED, and how we can state, let's say if it was 5 volts, maybe I want to state it to be not totally 5 volts. And that's what pulse width modulation is. I can say, hey, be not 5 volts, be 4.5 volts or 3 volts if I wanted to. Anything that's coming off of these rails right here is 5 volts. That being said, it's not completely, utterly 5 volts as far as the current is concerned. The current is already kind of resisted down. So an LED will survive quite long on this rail without a resistor. And for those nerds that are about to troll me, please just check some of the hardware on there to see that this side is in fact dummied down quite a bit on the current. So that side not. Alright, so that's your very beginning intro little experiment. Lighting an LED. Be afraid. Be very afraid. So let's look at software and how we can make that happen via software in the next video.